Is Schroeder, and he will talk about to catch a cheat.
I must have odd ears. This thing is funny.
If you prefer to hold the mic, you can use this one.
Nope. There we go. As long as you can still hear me. Good? Okay. So my presentation's on To Catch a Cheat. That's just sort of a catchy title. It's not really about catching cheats. It's about cheats in general. This is me. I do a lot of things, some of them well. And this stems from my interest in computational models of society, in particular those that use games. I first read The Evolution of Cooperation as an undergrad, and I've always wanted to do something in that area. I considered doing something in that area for my master's thesis, but I was diverted to something more circumscribed, and that was a good idea because I found this field to be very unwieldy. So my progress in the area is minimal, but you should take this as an introduction to the area and the announcement of a project. So I hope it inspires people to look into this. So we're interested in modeling cheating and its effects on society, effectively. There are three types of cheats that I can find. Overtly breaking the law is one. Another is when there's informal laws or rules of association between people that are informally enforced. And then there's cheats, or like hacks, which are exploits that probably would be enforced if people knew about them, but not everybody knows about them. So, for instance, let's go to video games, right? So when my first favorite video game was Double Dribble. Anybody ever play Double Dribble? It's awesome. But there's the total hack, right? Because you go to the corner and you fall out of bounds and you go flailing out of bounds and you make a three-pointer like 80% of the time. It's a hack, right? But if you don't tell people about the hack, then you can use it sparingly and get away with it to your advantage. If you tell people about the hack, or use it too often and people catch on, then it's not to your advantage. So roughly that's what we're modeling here. We'll be modeling instances of type 3. So the basic model is you have a group of players. It can be any number of players. Each round, players are paired off. They can be just one massive lottery, but what we have is 2-player lotteries, effectively. And it's a fair game initially, with payouts of 2 or 0 for an entry fee of 1. Each player starts out with 5 units of utility. These can be dollars, these can be anything. And then each round they're forced to pay 1 in order to play the game. Except there's exploits, and when people find them, they get more shares into the game, provided they find the exploit and then decide to use it. So that's the basic model. Now the caveat to that is, like I said, there's no formal policing of the use, but if somebody uses the exploit, then others are more likely to catch on and use it against them. So the most interesting question is one I won't answer, and don't even try, because I'm not a game theorist. But it's, what is the appropriate use rate of a known exploit according to rational self-interest, given that by using it you threaten to share it with others who may then use it against you? So that's a basic game theory question, which may be able to be answered, but I don't try to answer it here. I'm going to try to model cheating in society in an initial model without answering the question of the rational way of using exploits. So roughly I do that with the notion of cynicism, which is something that everybody has an initial amount of cynicism, but as they see other people using exploits, they gain more cynicism, and it makes them look for more exploits, and makes them more likely to use those exploits. Sort of So roughly influences and is influenced by observation of exploit used by others. Find that others using exploits, our cynicism goes up. As cynicism goes up, we more readily find exploits, and we readily use those we find in fear others are using them too. So that's the basic model. Now there's two ways in which people discover exploits. One is sort of independent of others' use of the exploit. It's sort of initial discovery. And we model an initial rate of discovery, also using cynicism, because as your cynicism goes up, you're more likely to want to look for new exploits. And then the second way is just to observe others using exploits, and if you catch them using an exploit, you can use it too. So the basic notion is it's just an initial use rate of the exploit. Once you have the exploit, it's an initial use rate of the exploit times the cynicism of the player determines the use of the exploit. And shares are given by a distribution. So if you decide to use the exploit, there's a certain distribution of added shares to your lottery game in that round. And also, if you catch somebody using a exploit, your cynicism goes up according to this basic factor at the bottom. So what we did is run a series of simulations. So a given simulation just is like I initially described, but it goes for 5,000 rounds of gameplay, and then we look at two distinct groups, those that survived and those that did not, where a player is said to not survive if they go to 0 utility. And we did this 1,000 times. So we took averages across these different lifespans of players. As you'd expect, we found that the utility of the players when they found the exploit was better for was better for those that survived than it was for those that did not. In fact, only 20% of those that did not survive found the exploit at all. And this is not entirely unexpected because the survivors obviously had shorter lives. They had less time to find the exploit. But finding the exploit early was important. That's what this data shows. As the cynicism goes up, the initial cynicism goes up, and the use rate goes up, this is actually a difference. So if it's negative, it means that the average for survivors is less time to finding the exploit, and if it's positive, it's more time for the survivors. So basically, as use rate and cynicism go up, the importance of finding the exploit early goes up. And this is more or less a validation of the model that is doing what it should. This is what we would expect. So going forward, and this is why it's more of a project announcement than a results announcement, I want to address these 6 things. So it should be assumed that people that know of an exploit or know of exploits in general and have a high cynicism would want to some way police the use of an exploit to prevent others from using the exploit indiscriminately, right, and giving away their secret too. So the growth of and how policing is done would be important. You can obviously ask for a series of games, not just this game, the influence of character of the players. You can add in reputation of the players for using exploits and how that makes other players attack them, for instance. And then you can have any series of games. So the whole economy can be modeled as games. So you can have any types of games and any types of exploits and any number of exploits for a given game. And then finally, alliances, which I won't go into, but we would like, obviously, a game theoretic analysis of any given model. So we would like a game theoretic analysis of that, but for now, we have simulations which can tell us important things too. So this is not a particularly Pythonic talk, but I wanted to mention that this kind of modeling work is really easily done in Python. I mean, it's think in code, and Python allows you to do that. I use Panda in the data analysis, and you should know that if you want to do a weighted lottery, you should use bisect, or look up bisect, because that's the easiest way to do it. So that's me, and hopefully I'm not long on time. So if there's any questions, let me know.
We still are trying to